infancy, Earth was a primeval hell. Bombarded by billions of asteroids and comets. The sun was much dimmer than today, and the moon much closer to the Earth. There was no water. The surface was scorched by ultraviolet radiation, and volcanic eruptions spewed noxious gases into the primitive atmosphere. How was this hostile planet transformed into an Earth where life could survive and humans evolve? Our Earth is over 4.5 billion years old. To help us grasp the enormity of geological time, imagine if we could compress the whole of Earth's history into the 24 hours of a single day. As we turn the clock backwards from midnight, we find that the first humans walked to the Earth at just 30 seconds before midnight. Dinosaurs appeared just before 10:50 p.m. The first multicelled animals evolved at 9:05 p.m. Before that, there were only single-celled organisms. The earliest life appeared just before 4 o'clock in the morning. This film is about the very first hour of the day when a series of extraordinary events transformed a violent and hostile planet into the world we know. But the story of Earth's conception begins well before midnight. Originally, our rocky planet was nothing but a cloud of dust floating in space. Dust that was created from huge, ancient stars when they reached the end of their lives and exploded. From these supernovas erupted all the elements that we have today: iron, carbon, even gold and radioactive elements like uranium. As the stardust cooled, it became more dense. Gravity took hold, and the dust cloud collapsed towards its center, forming a giant rotating disk, the Solar Nebula. In the center, a star. Our sun was born. Hydrogen and helium were swept out to the far reaches of the disk, where they condensed to form the gas planets. Left behind was a cloud of dust grains orbiting the sun.
They're circling around the early sun and little racetracks, and occasionally grains traveling nearby will collide. Something like this happens in your house. If you look under your bed, you find that little bits of dust are collecting together into big, large dust balls. And something like that must be what happened in the solar system, too. If they collide slowly and at low angles, then they can add up to a larger object and gradually grow.
As the dust grew into rocks, the force of the impacts generated enormous heat. Sometimes the colliding rocks simply destroyed each other.
If they collide head-on or at a higher angle or at higher velocities, then they'll actually break apart, like shooting a gun at a wall.
But some of the rocks survived. As they grew larger and larger, their gravity grew strong enough to attract even more rocks. After 10,000 years, these so-called planetesimals grew so large that they became spheres of rock 10 miles across.
Gradually they grow from golf ball size to rugby ball size, and then house size and township size. And then one or two of these objects would get large faster than anything else and become the big boys on the block.
Finally, around 20 of these planetesimals had reached the size of our moon. Eventually, they would collide and combine to become the 4 rocky planets that remain today: Mercury, Venus, Mars, and our Earth. It was midnight, and the story of our newborn planet had begun. It's an almost impossible task for scientists to work out the exact date of birth of our planet, because all the evidence of early Earth has long since been destroyed. The only clues the scientists could turn to were other celestial bodies created at the same time. Asteroids, the rocky debris left over from the formation of the solar system. Between the orbit of Mars and Jupiter, over 3 trillion lumps of rock are trapped in the asteroid belt. Some of them are as primitive as the dust grains which built the Earth. Occasionally, collisions knock the asteroids off course. And every year, 40,000 tons of asteroids are ejected from their orbit and fall to Earth as meteorites. Some weigh as much as 200 tons.
In Science News, a meteorite that lit up the skies over Canada is now shining a light on the distant past. A fireball streaked across the sky over Whitehorse and the southern Yukon early Tuesday morning. Residents there were treated to a spectacular blazing meteor that was so large it left this trailing dust cloud.
A local pilot was the first to spot this meteorite in Canada. Debris from the exploding fireball had landed on Tagish Lake, which in January 2000 was completely iced over. The pilot collected a few of the fragments from the ice. Realizing he'd made an important find, he sent a small piece to NASA. NASA's meteorite expert, Michael Zelensky, immediately recognized it as a carbonaceous chondrite, a meteorite formed from the same dust that built the Earth.
The last time we had a major fall of a carbonaceous chondrite was 30 years ago. So that means that it's about one time in a career you had this happening to you, and to have it happen to me in my career while I was still young enough to take advantage of it was a very exciting thing for me.
NASA scrambled a team of scientists to collect as much of the remainder of the meteorite as possible. This was the opportunity of a lifetime. 3,000 fragments scattered across the frozen lake could each contain clues to the very beginning of Earth.
Where would you like it cleared? There she comes.
The scientists hoped that the fragments would be uncontaminated, in the same pristine condition as when they were formed 4.5 billion years ago.
Kind of should concentrate on the wood.
If this meteorite was as primitive as hoped, it would reveal the exact chemistry of the dust grains that built the newborn Earth. With great excitement, Michael Zelensky began to analyze his first fragment.
This Picker meteorite is really special. In the first place, it has the highest carbon content of any meteorite and the highest amount of these preserved interstellar stardust grains of any meteorite. It has a very high water content as well.
Initial measurements suggest that the Tagish Lake meteorite is more like the earliest solar system than any other meteorite ever recovered.
It's dull, polygonal fractures, oxidation halo.
Already it's providing a chemical fingerprint of early Earth, but researchers will have to spend decades teasing out more of its secrets. Because these fragments were formed at the same time as the planets, they can also be used to accurately date the creation of the Earth. By using radioactive dating, Michael Zelensky and his colleagues have been able to calculate that the Earth's date of birth was 4.55 billion years ago. If
you date meteorites, what you find is that almost all meteorites have the same age, about 4.55 billion years old. They're all the same age. It's pretty monotonous. Within a couple of tens of millions of years to hundreds of millions of years, they all have exactly the same age. And so what we do is take the oldest of these ages and use that as the initial age of the solar system.
The history of our planet had begun. On our 24-hour day, the clock was ticking towards 8 minutes past midnight, and the Earth was about to experience its first major catastrophe. Radioactive elements trapped when the planet was formed were heating it from inside. At the same time, Earth's gravity was pulling in huge quantities of debris from space. A bombardment that generated excessive amounts of heat on the surface. The combined effect was catastrophic. When the temperature reached 1200 degrees Celsius, the iron began to melt and sink.
You think the Earth at some point was totally molten, a big droplet of melt just floating in space. When you have a totally molten object like this, the heaviest elements, and that includes things like iron, would sink to the center of this droplet, and the lightest elements, things rich in carbon and water, for instance, or light elements, would float to the top and float there like algae on a lake.
This gigantic migration of the elements is known as the iron catastrophe. The sinking iron accumulated at the heart of the Earth and created a molten core 3/4 the size of the Moon. As the liquid iron swirled around, it produced an invisible force that even today helps keep us alive: the Earth's magnetic field. Convection currents inside the liquid core behaved like a dynamo and generated electric currents. These transformed our planet into a giant magnet with north and south magnetic poles. Today, direct evidence of the continuing turmoil at the center of our planet can be found on the snowy wastes of Arctic Canada. Every year for the last 30 years, Larry Newitt from the Canadian Geological Survey has set off in search of the magnetic North Pole. He spends weeks at a time on the ice, hundreds of miles from civilization, and in temperatures as low as minus 20 degrees Celsius. Navigators around the world rely on Larry's work because he charts the exact position of the magnetic pole. Over the last century, it has changed position every year. At present, it lies 125 miles off the Canadian coast. The geographic North Pole is in a fixed position, but the magnetic North Pole is always on the move.
Over much of the past 100 years, it's been around 10 kilometers per year. But since about 1970, it started to accelerate, and now it's moving along at about 40 kilometers per year. If this keeps up, it'll reach Siberia in about another 40 or 50 years. But of course, that's a rather dangerous extrapolation. We don't really know where it's going to go.
The constant movement of the magnetic pole proves that the convection currents inside the liquid iron core are shifting all the time.
Let's get going.
To identify the latest position of the pole, Larry has to measure the strength and direction of the magnetic field at 8 different sites.
So I'm going to do 4 readings of declination and 4 readings of inclination, and 1 or 2 readings of total intensity. 89, 13.0. Since we don't know where the pole is, we can't just go there and take a reading. So we surround it, and then I determine its location by a process of, well, what amounts to triangulation. 268, 35.0.
Once he's found the location of the pole, he can pinpoint its exact position by using an antique dip circle. It's like a compass that points vertically instead of horizontally.
You see the needle in there? It's pointing straight up and down, and that's how we define the magnetic pole. The place on the Earth's surface where the magnetic field is directed vertically downward into the Earth.
Without the liquid iron core, the early atmosphere would have been stripped away, and life could never have evolved on our planet. That's because space is lethal. It's full of highly dangerous solar particles that can be 10 times more deadly than the radiation from a nuclear explosion. These particles originate from the sun when it spews out massive solar flares. A devastating solar wind streams towards the Earth at 250 miles a second. That's 1,000,000 miles an hour. If it ever reached the surface of our planet, it would strip away the atmosphere in a few thousand years. But the Earth's magnetic field creates a protective shield and deflects the solar particles. Without the molten core, today our planet will be a sterile, rocky sphere with little or no atmosphere. The tragic fate that befell our neighboring planet, Mars. 4 billion years ago, the red planet also had a liquid iron core and a magnetic field like our own. It built up an atmosphere and may well have supported life. But Mars is smaller than the Earth, so it cooled rapidly, and its iron core became completely solid. The planet lost its magnetic shield, and today its atmosphere has been scoured away by the solar wind. The surface of Mars is now a barren desert, seared by solar radiation. The time had reached 16 minutes past midnight. The iron catastrophe was over, leaving the rocks at the surface depleted in iron. Large areas were cooling and solidifying, but the Earth was still hostile and uninhabitable. Incessant volcanic eruptions poured hot gases into the thick, turbulent atmosphere. This alien landscape was enveloped in a noxious mass of hydrogen sulfide, methane, and steam. Humans could not have survived here. There was no oxygen to breathe and no ozone layer to block the lethal ultraviolet radiation. The scene was set for the next trauma in the planet's early history, an event so catastrophic that it nearly destroyed the Earth, but created the Moon. Since our ancestors first looked up at the sky, the origin of the Moon has remained a mystery. Then, in the 1970s, planetary scientist Bill Hartmann proposed one of the most radical scientific theories of our time.
I'm always looking at the moon and thinking about its phases, and when I was a little kid I had a telescope. I used to be out there drawing craters on the moon and was very excited that I could even see these craters in mountains and so on. So it's always had a special interest for me.
This telescope at the McDonald Observatory in Texas has been scanning the Moon for over 40 years.
There's the moon coming in.
You want to point to some craters?
Yeah.
Point around?
Yeah.
Back in the 1960s, Bill and every other planetary scientist had hoped that the Apollo missions would solve the mystery of where the Moon had come from.
One of the pitches to sell that program scientifically was that we were going to be able to go to the moon and find these old rocks from 4.5 billion years ago, and they were going to tell us everything about the origin of the moon.
Astronauts were instructed to collect rock samples from the Moon's ancient highlands.
Look at the size of that biggie. It is a biggie, isn't it? This one right here? That's it. You got it right there.
After the rocks were returned to Earth, scientists calculated their age using radioactive dating. The results were astonishing. The Moon was younger than the estimated age of the Earth. And there were more revelations.
The biggest single surprise was that the materials on the moon had exactly the same chemistry as the Earth and different from any samples that we have anywhere else in the solar system. So that pretty well forced the idea that the moon has to form from the same basic material as the Earth.
There was another puzzling fact for Bill to consider. There was very little iron in the lunar rocks. In a flash of inspiration, Bill came up with his highly controversial theory that the Moon had been blasted from the outer layers of the Earth.
We came up with this very simple idea that maybe as the Earth was forming, at our distance from the Sun, somewhere nearby, made out of the same material, was a second largest body, which got pretty big before it finally plowed into the Earth.
Bill's theory was revolutionary. He proposed that 50 million years after the formation of Earth, a rocky planetesimal was still at large. This huge mass of rock, about the size of Mars, was set on a collision course with Earth. On our 24-hour clock, the time was approaching 16 minutes past midnight but there was no moon in the sky. We may never know the exact chain of events that created our moon, but one scientist, Bill Hartmann, has suggested that it was formed when a rogue planetesimal thousands of miles across struck the young Earth. The heat of the impact melted both the planetesimal and the outer layers of the Earth. Together they fused into one planet, a new, larger Earth. Vast amounts of molten rock were ejected into orbit. Over the next few thousand years, the debris coalesced to form the Moon. When Bill Hartmann first came up with his theory in 1974, few other scientists believed him.
All of us were taught as junior geology students that all processes in geology are slow, one sand grain at a time, erosion, and so on. And people would actually come to us and say, you know, we really shouldn't consider that model until we've exhausted all other models.
It was another 10 years before Bill's theory began to be taken seriously. It took hundreds of computer simulations to finally prove that the Moon could have formed from debris flung out from the Earth. Today, Bill's theory is accepted as the most likely course of events.
So it's been a long, slow process, and it's been really fun to see, you know, a little idea that you had a long time ago suddenly blossom forth as a leading theory.
It was 16 minutes past midnight, and the Moon had arrived. The Moon was much closer to Earth than it is today, and it appeared 15 times as large. As a result of the massive collision, the Earth was spinning 5 times faster than it does today. Each day was just 5 hours long. The proximity of the Moon created an enormous gravitational pull on the surface of the Earth. The ground rose and fell by as much as 200 feet when the Moon passed overhead. The drag on the Earth's crust slowed our planet's speed of rotation and forced the Moon to orbit further and further away. It has been moving outwards ever since.
The idea of being able to measure the movement of the Moon away from the Earth has always been a challenge. And so when the astronauts went to the Moon, one of the things they did, they carried out this big device, which was a reflector, a retroreflector, that would beam a laser beam back in the direction that it came.
Back on Earth at the McDonald Observatory, astronomers installed a powerful laser strong enough and precise enough to target the reflectors. In 1969, scientists took their first measurements of the time it took for a laser beam to reach the Moon, hit the reflector, and bounced back to Earth. A round trip of 2.5 seconds.
Doing this year after year after year, we've actually been able to confirm that the Moon is moving slowly away. We not only get very exact information on the orbit of the Moon, but we can actually see the orbit change.
Measurements from the laser have confirmed that the Moon, currently 238,857 miles from the Earth, is moving away 2.5 inches every year. The immense collision that formed the Moon also caused our planet's axis to tilt over at an angle of 23 degrees. Without the stabilizing influence of the Moon, the Earth would wobble dramatically about its axis. the planet would experience wild fluctuations of weather, making it impossible for anything but the most primitive life forms to survive. Until now, scientists had assumed that it would have taken at least 1 billion years before our planet was cool enough to form a thick crust and for water to appear on the surface. But startling new evidence from Australia has caused them to rethink that timescale. These rocks in Western Australia are part of the oldest land surface on Earth. They have miraculously survived the never-ending formation and destruction of the crust that's been going on ever since the Earth was created. But here, geologists have discovered, embedded within the rocks, tiny zircon crystals, the oldest material ever found on Earth. When geologist Simon Wilde extracted the crystals, he discovered something extraordinary about the development of early Earth.
When we look at the chemistry in detail, we find that it's consistent with having grown in a piece of continental crust. And this is the first time that we've been able to extend the history of the Earth back to 4.4 billion years.
Simon's discovery suggests that the Earth must have recovered very rapidly after the trauma of the Moon's formation. The age of the zircons revealed our planet must have cooled and formed a crust as early as 12 minutes to 1 in the morning on our clock. These tiny crystals are the last surviving fragments from the first hour of the Earth's life. But the zircons held a far greater secret. American geologist Stephen Morgese carried out his own unique chemical exploration of the tiny crystals. He discovered an even more startling fact about the conditions that prevailed on early Earth.
The Earth's crust can be thought of as a rug in an old house. Over hundreds of years, and people walking over this rug, they would wear the rug away until there were a few threads left behind. Well, the geological record is similar to that, is that from this early time we really only have these tiny, tiny minerals that we find in the Jack Hills of Western Australia.
The zircon crystals are formed from a combination of zirconium, silicon, and oxygen. They're nearly as tough as diamonds and can survive almost any upheaval in the Earth's crust. The crystals are the size of pollen grains. Stephen had to pulverize tens of kilograms of rock into tiny pieces to find just a few dozen very old crystals. He placed the oldest zircons inside an ion microprobe to analyze the chemical composition of the oxygen atoms inside the crystals. In January 2001, Stephen announced he had made a revolutionary discovery. The oldest zircon crystals contained a type of oxygen called oxygen-18. Oxygen-18 could only have been present if the crystals had grown in the presence of large quantities of water. Geologists had previously believed that large amounts of water first appeared around 1 billion years after the formation of our planet. The oxygen-18 revealed that water was present on the surface of the Earth much sooner, as early as 200 million years after its formation. The time was still only 12 minutes to 1 in the morning.
Not only was there crust present, which came as a surprise to most of us, it looks like, from some of the zircons, that crust interacted with large volumes of liquid water.
The crust must have been cool enough for water to condense into lakes, or even, as Stephen believes, oceans.
By 200 million years after the formation of the Earth, you can imagine a landscape of islands and small continents bathed by a primitive ocean, wherein these zircons were formed.
The presence of water would have been a vital ingredient for the origin of life. No living organism can exist without it. But there remained a mystery. Where did the huge volume of water in our oceans come from? One possible source could have been comets. The evidence for these ancient impacts is now impossible to find. The original surface of our planet has long since been eroded and destroyed. Planetary scientist Bill Hartman has gathered evidence on the conditions of early Earth from our nearest neighbor. The Moon reveals the awesome scale of the bombardment by asteroids and comets.
Every one of those craters was a meteorite explosion at some time. That's incredible. Oh, there's a nice one with fractures, and another bigger crater out here, small craters.
The Moon is scarred with craters, some of them hundreds of miles across. During the first 600 million years of its history, the surface was bombarded with massive chunks of debris. Planetary scientists have calculated that the Moon has been ravaged by more than 1 million major impacts. Because of its greater size and gravitational pull, the Earth would have attracted even more debris, possibly up to 14 million impacts.
We all hear about the impact 65 million years ago that wiped out the dinosaurs. And you're getting that kind of impact something like once a month on the early Earth. But this rain of debris left over from the formation of the solar system continues for several hundred million years.
Comets contain dust and frozen water vapor left over from the birth of the solar system. Like giant dirty snowballs, roughly half their mass is water. One of NASA's top comet experts, Michael Mummer, believes that comets could be the source of the water in our oceans.
One possibility is that Earth's water was delivered by the impact of bodies from beyond the Earth. These would naturally be the comets, which are rich in water. The proof in that would be to measure the composition of cometary water and to compare that with the composition of water in our oceans.
Over the past 20 years, just 4 comets have passed close enough for scientists to study in detail, including Hale-Bopp in 1997.
A comet like Hale-Bopp would deliver about 10% of the water needed to fill one of the Great Lakes. This is a lot of water. Of course, the oceans are much larger, and so we need many more comets to fill the oceans. But we're fortunate. We had many such comets in the early solar system, so we have every reason to believe that it was cometary delivery that brought water to the early Earth.
His theory suggests the force of the impacts evaporated the comet's ice, creating dense clouds over vast areas of the Earth. The heavily laden storm clouds would have produced a deluge of hot, acidic rain that continued for millions of years. At first, the water would have formed lakes and rivers, until eventually there was enough to almost completely cover the globe. But there is a problem with Michael Mummer's theory. Earth's oceans contain a mixture of normal water, H2O, and a small amount of more exotic water, HDO, known as heavy water. In the comets analyzed so far, the proportions of each kind of water don't match the composition of our oceans.
They have twice the amount of heavy water that we see in Earth's oceans. So if they were the comets that delivered Earth's oceans, they wouldn't fit the bill, basically. They don't have the right properties.
But Michael hasn't given up yet. He may have been looking at the wrong type of comet. The comets he's analyzed so far originated at the outer reaches of the solar system. What he needs to analyze is the water in comets that formed much closer to the Sun. These were formed at higher temperatures and would have incorporated a much lower proportion of heavy water. Michael's hoping that the comet passing near to Earth tonight, Comet Linear, is one of these rare comets.
There it is.
There we go. Go one more step.
Analyzing Comet Linear at such a distance is at the leading edge of astronomy. This is an extremely difficult experiment with no guaranteed result.
Moment of truth.
How we're looking for the comet.
You gotta try to shoot right to it, right?
Yeah, I'll try.
All right. As soon as he has acquired it, we should see an image of it on this screen.
There it is.
There it is. All right. Yes, sir. Right there. You can see the elongated material flowing outward from the nucleus. Joel, that looks excellent.
Once they've homed in on the comet, Michael and his team can begin to analyze what type of water Comet Linear is carrying.
Bring up the spectrograph.
Yeah. It's a moment of truth here. A and the B. 87 was the first one?
Yeah.
All right. People often ask, how can you measure water in an object that is 100 million miles away? We do this by a method called spectroscopy. It's a little bit like taking fingerprints. The little ridges on your fingers look different for every person. And in the same way, the light that is emitted by a given molecular compound is different. It emits at different wavelengths. There, a little dark spot.
I think we just need more.
Let's do the long one.
It's this one, right?
But new science is rarely easy.
It's right next to this one.
While the spectrographs show that Comet Linear has plenty of water on board, it's far less bright than expected, and the team are unable to obtain the critical data on heavy water.
It did not brighten as expected. This was a bit of a disappointment. Comets are quite fickle. You know, they're unpredictable. In some ways, they're like cats. They both have tails, and they both do what they want to.
Michael will have to wait until the next comet comes close to Earth for another chance to prove his theory. Until then, the origin of Earth's oceans will remain a mystery.
One of the key things that every scientist keeps in mind is you should never fall in love with your theory. So it's an idea, it's a hypothesis, it fits all the known facts, but it has not yet been proven. And we must be willing to give it up and modify it if it is not proven. But we will learn something in doing so.
The Earth had survived its early catastrophes, and only 1 hour of our 24-hour day had passed. The young planet was still very different from the one we know today. Its oceans were corrosively acidic, and the atmosphere full of noxious gases. This may seem a hostile world, but many scientists now believe that these conditions were perfect for primitive life to take a hold.
Very little is left behind from the Earth's earliest time period, but what is left behind is revealed to us a planet much more complicated than we ever thought. with different rock types, liquid water present, and the kind of planet that we might expect life to emerge on.
The scene was set for the next great chapter in Earth's history, the origin of life.
Do we know if life was around 4.3 billion years ago? Well, who can say? We can say, however, that the template, the ground underfoot, was there. Could life have been present? Why not?
In the next program, we will reveal how scientists have discovered that by 3 minutes to 4 in the morning, tiny life forms were already thriving in this hellish world. And it was this primitive life that transformed an alien planet into our own unique Earth, where humans could evolve and survive.